Dr. Ann Bowles. I'm a senior research scientist at Hubbs-SeaWorld Research Institute, and I direct the Animal Behavior and Senses program here. Today I want to talk to you a little bit about disturbance of animals. It's a controversial topic, but an awful lot of people think disturbance is trivial. The truth is that disturbance for animals is just the same as it is for people. If it disturbs something that's important, then it's important. So we're going to talk a little bit about the kind of work that we do to study that topic. So we started this out a long time ago, back in the 1980s, when the space shuttle first started taking off from Vandenberg Air Force Base. And at that time, people didn't know very much about that. There wasn't very much research. So we were starting from ground zero. Initially, the concern was that animals would be terrified and that they would run all around, and so we treated them as though they didn't have the sense to pay attention to their environment, see what's happening to them, and understand the best strategy for coping. And what we've discovered over the last, many, many years, 40 years almost, is that these animals are fairly sophisticated if they're familiar with something that's new and different. Sounds are a particular area of expertise for us, but we also deal with disturbance related to just putting human-made objects into the water, like fishing gear or bits of aquaculture facilities. And what we've learned is that, yes, if they've never heard it before, they rush into the water, but they're not doing it in a stupid way. That was the end result of our early work out on the Channel Islands.
Dr. Bowles, what do you mean by a stupid way? Meaning panic?
Yes. In other words, to be panicked, the sound must be coming from it has to be like a snake rattling right next to your feet. You're going to react before you have a chance to think about it. And animals do have those reactions. But in general, what we're finding is that they assess the situation before they have a reaction in the same way that you would, unless the disturbance, whatever it is very immediate. And after that, their reaction the first time is not a very good predictor for how they're going to react thereafter. So we did a bunch of experiments with little noise-making devices intended to chase animals away from nets. And what we discovered is that the first time, yes, they react strongly. They signal each other that there's something unfamiliar in the environment, blow bubbles, which is a pretty common marine mammal response to the unexpected. But the second time, the reaction starts to be different. Sometimes they go up to it to find out what it is. That's exactly what you would do in the same situation, something unfamiliar, approach, get information. Some animals have really strong defensive responses, and so they stay away from it, and we need to identify those species. Little dolphins are particularly prone to that behavior. Sometimes if they're bigger and stronger and more able to care for themselves, they're actually going to go up and make a fast pass at it as though they were going to attack it. So we have to expect not one response, but flexible, intelligent approach to the problem. Another example with the same stimulus is manatees. Turns out manatees don't see very well underwater, but they hear great. So if they hear something unfamiliar, they're actually going to go up to it, which might be exactly the opposite of the reaction that you want. So that just kind of gives you a feel for it. So the question is, does this mean that people who are all upset about disturbance in animals have nothing to worry about? They're making all of this up? No. The answer to that is definitely not. What we have to be sensitive to is how whatever it is that we've put in the water, whether it's a sound or an object, affects the animal's ability to do what he needs to do. And in biology, we call that how they function. If you're messing with their ability to function, then you can expect negative results. If they can behaviorally adapt to the situation, then there may be very little effect at all. And that's where the science that we do comes in. Our job is to look at exactly what the animal does when they come into contact or they hear the sound or whatever it might be, and then figure out, okay, how do we make what we put in the water so that it doesn't interfere with the animal's ability to function? So for example, for the manatees, clearly putting a little pinger in the water to protect them from gear is not going to be the answer, because all it does is attract them. We need to put gear in the water in a way that doesn't attract them and doesn't allow them to become entangled.
Dr. Bowles, a moment ago you mentioned different species, different sized marine animals responded differently. Some attacked like, or some more of a defensive response. Can you elaborate on a couple of specific stories?
Well, I can give you one specific story. Killer whales are a top-level predator in the ocean. They eat just about everything else out there. And it turns out that they're really smart about figuring out how to steal fish off of fishermen's lines. So in the Prince William Sound in Alaska, the Saltonstall Kennedy program funded us to do a study that allowed us to show what I mean by working the problem. Up there, killer whales were attacking fishermen's lines. They were smart enough to figure out what the sound the boats were making, exactly what that sound was when they were hauling in fish. So the fishers couldn't win. They start hauling in their fish and the killer whales show up. And in fact, the killer whales even figured out how to deal with the problem of two fishermen hauling their lines simultaneously. They just split up and monitored both boats. So this was a serious problem. Animals were getting shot. It wasn't a great thing at all. But we tried to understand, okay, so how are the killer whales actually identifying these guys? Because they can't swim over the whole Gulf of Alaska. They have to specifically home in on a given boat. How are they doing that? Well, one logical suspect is sound, right? Underwater sound has the same function as vision in air does. So you want to monitor what's going on underneath the water in the Gulf of Alaska, you just listen. So presumably they were listening to sounds that were being made by these boats. So we used information that had been actually collected here at Hubbs-SeaWorld on the hearing characteristics of killer whales, and we measured the sounds that made by boats and figured out pretty much how far away these animals were picking up the sounds from the boats. Well, underwater, if you reduce sound by 6 dB, you cut the range at which the animal...
I'm sorry, Dr. Bowles, BU, you said cut it by 60 BU. Could you explain that?
Underwater and in air, in all media, sound is measured with a logarithmic scale called a decibel. If you cut down the sound level by 6 dB, you cut the range at which you can detect it by about half. So it really makes a big difference to be able to get the level of the sound produced by a boat down, because it means that the animal has to work a whole lot harder to get to the boat when he finally detects it, and he can't detect it from anywhere near as far out. So this is the answer that we were able to come back to with those guys, and we did some initial experimentation. Well, of course, at that point, people figured out, oh, wow, this problem can be solved more easily by changing how the fishing rules work. But that's the point. You work the problem. And that's our job, is basically to come up with a win-win scenario where the most efficient possible solution is what's available for any given situation.
So what did they change in their fishing strategies to prohibit the whales from showing up during their backhauling?
Sorry, the season and the permits to fish were spread out more. So that was the strategy. You make taking fish off fishermen's lines more expensive for the whales. You make it so expensive that it's just not worth doing. So that's basically how the problem was solved. Now, this is a chronic issue in a lot of parts of the world because both killer whales and sperm whales are prone to this kind of depredation, and they're working it in different ways in different parts of the world. We hope that we can carry the approach further in other situations in the future.
Dr. Bowles, you've talked a lot about the work you've done working with sound with the marine animals, but I understand you've done your work with some land-based animals. Can you tell us about that?
We've done work on terrestrial animals as well. In fact, we got our chops partly working on terrestrial animals back when the program first started. So we have done work for both the United States Navy and the U.S. Air Force on the effects of noise on threatened and endangered species. Aircraft noise has been a particular problem for both of them, because they fly jets at low altitudes or helicopters at low altitudes, and the concern has been that this would disturb the wildlife and add to the level of threat for these species that are already in trouble. Now, this is a good place to talk about the principle that I brought up initially, that animals have to make a go of life in the environment. So whatever it is that's most important to them, that's what's likely to be having the most effects on their success. So in all of these programs, we've made a point of designing them so that we were also keeping track of what was going on in the habitat. And one really good example of this is work that we did with Miramar and Camp Pendleton, looking at the effects of helicopter overflights on least Bell's vireos and California gnatcatchers, which are both managed species here in California. And we looked at the habitat that they were living in over periods of years so that we could see variations, and then also measured the amount of noise that they were receiving, all sorts of aspects of the noise that they were receiving. And in both cases, what we discovered is that the habitat, it's basically the line is, look first at the habitat because it's the habitat, stupid. That's what they have to worry about. And the reason that the aircraft potentially weren't causing more problems than anyone expected is because the amount of time that the aircraft were actually present, yeah, they're loud, but the amount of time that they're present is not very large. So from the perspective of the animal, I'm trying to get my job done, being able to listen for things wasn't being affected more than a small percentage of the daytime, and the rest of the time it mattered for things like how much rain was falling, whether or not there were plenty of insects around, how much water was there, where were they relative to the edge of a slope, all this kind of thing. So that's another example of when you're studying disturbance, you really have to work the problem. You have to think about how you're affecting what the animal needs in order to make a go of it.
Were any changes instituted based on the work that you did, working with the Navy and the Air Force?
Well, in the two situations that I'm describing, there wasn't a particular need to do that because the amount of noise that the organization was putting into the air was very small. So there wasn't a significant sign that it was affecting them at all. So why make a change?
Dr. Bowles, you've done a lot of fantastic work for Hubbs-SeaWorld Research Institute. Do you have a current project, something, a wish list that you would hope you could tackle today if you had the time and resources?
So scientists always have that dream of being able to do the next step in the work that what we would do with a lottery if we won it is science. So right now, we as a country, in fact worldwide, we're conducting a huge unplanned experiment in reducing disturbance. We didn't want it to be this way. It's a terrible thing for a lot of people, but from the perspective of a biologist, you look at the fact that people have simply been locked down. They're out of the environment. They're not driving. They're not flying. They're not, things aren't being shuttled around in boats. And to take advantage of that is, everybody in the business who does disturbance work is looking at this as an incredible opportunity to find out what the impact of just our normal activity is on the animals that we live with. We couldn't have planned it, but it would be a terrible shame not to take advantage of this opportunity, and we're all really, really wanting the resources to take advantage of it.
So something fascinating's come out of this crisis.
So it's the silver lining, the tiny silver lining on what's otherwise a terrible human tragedy, is the fact that questions that we could not have designed experiments to study can now be studied if we only get out there and take advantage of the situation.
All right. Well, thank you for your time, Dr. Bowles.
You're very welcome.